All right, here we are. Good. So right now I'm looking at the Node.js course, specifically the GraphQL. I can make a quick recap of what is GraphQL, which is a new way of building front-end and back-end applications. It is a query language. But the beauty of this is that we can see how all of these different pieces of data relate each other in our server. So it all starts by describing the data using schemas, and if you want to ask for the data that you want, you rely on queries. A query is much like selecting property on an object. That one of the great things of doing that is, since the query really match closely what the return object will be, we can predict what our query will return, and that includes the property from the object. So making GraphQL queries very intuitive about which data are we going to fetch, so we can predict what our data will look like regardless how the data is stored. Okay, whether it's a relational, key value, document based graph, or Y column. So this is something that it started in 2012 by Facebook, and since this is a new way of building API, the two main challenges, the problems that GraphQL solves comes from RESTful architecture, where if you want to query multiple collection of values, you have to make individual requests and you get a separate response. And if you want to combine that data, you have to make multiple, or you have to query multiple collection of value. And this is something that first is not performant because it increases the load time by making this additional unnecessary request, meaning that this is something that they call overfetching. Underfetching. So underfetching is that. So we lose time making additional extra round trip requests for querying multiple collections to combine that data in the front end, which increase the page load time. That's one of them, the underfetching, and the other is the overfetching, that the server send additionally unnecessary data, so that we need to filter out all of the data on the client side. And one of the advantages of GraphQL is that by having one single entry point, we can eliminate the overfetching, underfetching. We also have this schema. Okay, so we have a documented API, and this speed up the development, of course, which is one of the trade-offs if developers are familiar with that. Okay, because otherwise, because this is not a RESTful architecture, well, the learning curve might be quite steep, and also catching methods is something difficult. This is an advanced topic, but GraphQL show you how to do that. But why this is a problem? Because in contrast with RESTful, where we already have catching methods that works, so with GraphQL we need this particular way of doing things, right? And the other disadvantage is because GraphQL add flexibility. This comes with a price, the complexity, but it's okay. Uh, and this is okay because I started to see, for example, is the specification website made by Facebook in 2012. Also, the frameworks that allow us to build this GraphQL uh, interface, for example, for the client side, right, to interact with a GraphQL server, right? Uh, for example, Relay, that is a React. This is using React framework, and the Apollo, which is a more high-end device, or is a more high-end product for building front-end and back-end GraphQL application. Great. So before dive deep into that, I look at how can we create GraphQL server from scratch as one of them, and how to create GraphQL query. So for the GraphQL query section, I look at how can we create our first GraphQL query using this browser built-in tool like graphical, uh, graphical, graphical. Mm-hmm. Uh, what about the code? No. Graphical, and is this. Swappy this. Okay. So it is GraphQL or this is Swappy GraphQL. Okay. So this, right? So welcome to GraphQL, graphical. Okay, it's an in-browser tool for writing, validating, and testing GraphQL queries. So it's starting to show how can we create that, and especially some cool things such as not only the query but also is the documentation. All right, to see you can see all of this query that you can do. So our API is now organized in type and fields rather than endpoint. So making additionally uh, extra requests query multiple endpoints to combine our data in the front end is unnecessary. So uh, with that, right? Then I look at how can create a GraphQL server from scratch and understand is things like the the type system. Understand first is we're going to use Express, this web framework to allow us to build a web server because it is easy to handle routing with Express app. Okay, that's one. The other is importing is the GraphQL package for that, right? Uh, and understand how to build an scheme. So here is using is the type system, and if you look at the type system here from the GraphQL specification, GraphQL stack here, okay. So the type system is where you define is the GraphQL service capability, and it is used to verify if a request is valid to guarantee the type of the result and describe the input values of a variable to determine if the value provided at the request time are valid. So for example, parameterize queries. Okay. And I also looked at in any GraphQL query, the entry point is defining the type query for that. And a more dive deep into using tools like Postman or Insomnia to test your API, to see how that works underneath the hood. After all, you're making is an HTTP postgre to that GraphQL endpoint and sending the proper data for that as a query, and then you get the data you want. But to make our life much more simpler and easy, so we rely on GraphQL. Okay, so then I started to design from the Node.js core an e-commerce schema. Why? Because, well, to apply this to a more realistic scenario and see that deep nested objects are very common in any e-commerce application or any other application with some technical data. So making GraphQL query a perfect candidate. And it is actually very easy. How can we query really complex data structure to get exactly the data that we want? So our API, as I mentioned, is organized in type and fields rather than endpoints. Okay? So GraphQL tools, okay, here are a way to first make our life much more easy by answering a couple questions like, how can we modularize our server by breaking down our schema into multiple files? Organize our server by functionality, and how to organize our server in a way that when we add more complex data to fetch our data is make it maintainable. So that we guarantee is the maintenance for that. Okay. So GraphQL is a set of utilities. It's an open source set of utility for this purpose, right? Under the hood, Apollo use this GraphQL tools package to provide their service. And especially if you want to align to a particular company, you must know, and it's up to you and perhaps the shareholder, the product manager, the CTO, to decide if they want to align to a particular company, because otherwise you might lose flexibility, right? Especially if something wrong or that for some reason that application or that product uh, end in its service or it reach to their to a particular life cycle service to the end of that life cycle. Uh, I saw that using its GraphQL. Okay. Uh, yeah, so I saw that using GraphQL is essentially good, or this GraphQL tool is essentially good for modularize our GraphQL server with schema. I also look at how can we do that, relying on package like makes executable to define is a type system by breaking down our types into GraphQL files. What you define is your type, and inside of your file you're going to define is the query type and add the proper query you want to, right? So after all, that particular approach is something good, especially uh, for Apple. For that particular approach is good when you define types properly and there is no name conflict. So I look at that, and question uh, is there any package or a way to identify if there is some name conflict from this GraphQL tool? Because what happens if you define, for example, the same, for example here, what happens if you define is the same, you define product and review, I don't think it will check that. For example, you define here product, okay? If you define here product for that, then you say, hey, you know what? It's going to affect this product, which it will be an array of four of product, right? Product one. So if you define here, this is just a test. Okay. If you define here, oh my god, NVA in use, version 14. An npm start. Okay, if I navigate to GraphQL here, and for some reason I just want us to fetch this product, okay, product one by the products one, exactly, because there is no resolver defined here. But product here is something that this is a type that has previously defined. So there is no type checking here. Okay, that's not necessarily bad, but can make unnecessary lengthy and heavier your package to production. But in any case, I think there must be other package that allow you to do that. But right now, since I'm looking is at the how can we modularize our GraphQL applications with schema, relying on GraphQL tools like the or from the npm package GraphQL tools using the next executable function to define is the type array. Okay, after all, it received a string of that, and to concatenate all of that and to make that as a string, I use a package called low file sync. Okay, it's important to note this distinction because, well, it will hold the execution of the server until it finds all of the proper files with GraphQL extension and load them right here. So that's great. That's something cool. That's actually pretty interesting the way how you can do this. And the other main component in any GraphQL server are resolvers. So what are resolvers? The answer lies on how we query a GraphQL server. GraphQL always makes sure that a query is valid, and if it is, then execute that query, and the property while executing that query, the value of that property is determined by a function called resolvers. So TLDR resolvers is a function for determining the value of a property, period. And if you define a GraphQL query schema, okay, so each property execute on the server the proper resolver, and once the server has gone through all of that resolver, or once all the resolver are done, okay, or when the server has called all the resolvers found in that query, I prefer to use that sentence, okay. So when the server has called all the resolvers found in that query, then it grab all those values and send it back to the front. Okay. So because creating resolvers in our schema is something that can be easily it's something that it can be easily not scalable, hard to maintain. So I rely then on how can we modularize our GraphQL query using or for resolvers. And again, we follow the same particular pattern as with our schema, and we're going to load those files into a type resolvers, or into the resolvers array, like here. So we're going to load all of those separate files in the product, or in the way of how you make your resolvers modular is by defining a function called resolvers that follow a particular structure, which is the query, and then as you define is your queries, right? So for example, in the product resolver here, the beauty of this resolver is that we can make asynchronous query, or we can make asynchronous API call or database API call to figuring out and then return that data to the client. So we test that with promise, okay? And a more interesting thing is to look at the anatomy, the resolver's anatomy. So the first argument is the parent, which is the root value that you provide. The other is the argument. It is used for parameterized query. Okay. So argument here is when we use parameterized queries. For example, if you want to filter out data with a particular criteria and then return that result to the front end, and we have the context data that can be shared across different resolvers. For example, you want to share, and for example, in authentication, you want to share the user if a user has login in different resolvers. And then we have is the info that indicate the state of the operation. Okay, but here, if we another this is a good practice. If you, for example, and you're not going to use a particular argument, okay, from this resolver function, use a underscore for that. Now, okay, so here we are in how can we modularize our GraphQL server using resolvers. And here, by again defining is this file where instead of calling directly inside of a resolvers API calls. So most of the time you're going to rely on a layer or a data layer. For example, the products model, where this is because if you want to build scalable and easy to maintain applications, that's a particular approach to do this. So this approach comes with this, or it comes. This approach comes from this, by the way. This approach comes from this website, right? Where the idea of looking at this is explicit architecture. Furthermore, these concepts have all passed their battle trial and are used in production code on highly demanding platforms. One is a SaaS e-com platform with thousands of web shops worldwide. Another one is a marketplace, live in 2 countries, with a message bus that handle over 20 million messages per month. Okay, this is something interesting. And this post is part of the Software Architecture Chronicle, a series of posts about software architecture. In them, I write about what I have learned about software architecture, how I think of it, and how I use that knowledge. The content of this post might make more sense if you read the previous posts in this series. But again, this is from H. Graka, alright? And again, this is something that you might use as you need it. Right? This is something that you might use as you need it. This is something that you might need as you need it. Alright? But it's okay to know, it is good to know this. Alright? So, back here of the reason of why we have a data layer access again is to modularize our application in a way that makes it more scalable. So, because from our resolvers, or as like we like to make the comparison with RESTful architecture, which is the controller, so resolvers will be or will behave somewhat similar to that with the controller for RESTful architecture. And the resolver, instead of handling this API logic or this data access logic, you create a file here, okay, where this is when you're going to perform those asynchronous operations. Okay, so for the sake of the example, here we just hard-coded this data that is being loaded from in memory, and defining is all of the data access function, like get all products, get product by price, get product by ID, and then export that so we can make use of them in the resolver, particularly here. So we can make use of them in the resolver. Another interesting challenge was, well, parameterized queries, or how can we filter out data when we ask for them. And since this is this section, we define as a, what do you call this, in the GraphQL, a query product by price, okay, what you're going to define is the type of data in those arguments and what it will return. And the same for get a single product. And again, because resolvers behave similar to controllers in RESTful architecture, product by price and products here, we call that data access function from the data layer. Here is the product model, okay? And we pass the argument for that. And we delegate that logic or operations to the API. In our case, we already handled that operation here, okay? And this is how, for example, when we make a query, okay? And to reload this. So when we make this query, and we ask for because exactly. Let me run the server. Okay. What about now? Cannot query field review and type route. Do you mean reviews? Is reviews? That's right. And there you got it, right? So here we're making is a parameterized query, passing is the data in a particular range here. So we get is the red shoe. Here I want you to give me is that particular product with the ID of red shoe, along with the description and the reviews. Okay. So because it doesn't have any review, it's saying you know, and the orders here. Again, this is just to see how easy is to query really complex data structure. Okay, good. Because now, after I saw that, how can we filtering with queries and resolvers? And how can I create that from scratch? Then I look at the mutations in action. So believe it or not, the GraphQL is not only for fetching data from the server, but also we also need to update existing data in our GraphQL. So we need to create new data and delete data that is not useful. So what's the GraphQL way of doing all of the things? So what's the GraphQL doing? Updating creations and deletion, the CRUD operation. So far we have used query, which is the keyword that is used behind the scenes when you don't pass any keyword. Okay. And let's find out in this video about yes. So far we have used query to fetch data from our server. So that's the most basic operation that GraphQL support, fetching data. With API getting existing data and reading is probably the most common thing you will do. Very, very important thing to know. That the most basic operation GraphQL support is fetching data, because with APIs, getting data and reading it is probably the most common things you will do. That's why GraphQL focus on doing queries really, really well. But in any real-life backend application, we need to support all of the CRUD operations: create, read, update, and delete. So mutations allow you to change the state of the data: create, delete, or update. So because I saw the two main components in any GraphQL server, schema and resolvers, now I'm looking is at the two main type of operation that GraphQL server supports. which is query and mutations. Again, two main type of operations. Mutations are very similar to query. Okay. Yeah. So mutations are very similar to query, and under the hood, the key thing is that we use mutation keyword that we're about to make some change, and not just to fetch some data. So mutations is from so mutations are like the HTTP post, delete, and put from RESTful architecture. Okay, so what they're doing here is just to simplify the number of operations that we can perform. Under the hood, they rely on the HTTP. Okay, but again, this is a layer or a new query language. That the beauty of this is now is focused on how all of these different data in the server relate each other. So this layer of abstraction put two operations, for example, when you define CRUD operations in RESTful architecture, you have a create. So if you create in CRUD operation or in CRUD application, create, read, update, and delete. Right? In CRUD applications, the create is performed by an HTTP post request. The update or the read are performed by a get. The update by a put, and the delete by a delete. Right? So you have here four operations that belong to the CRUD applications. Right? And also you have is, for example, the options in HTTPS and the headers. But again, this is focused on the CRUD operation. However, this is from RESTful architecture. So for each HTTP verb, get, post, put, and delete, you have its equivalent in CRUD operation. So create, read, update, and delete. However, with GraphQL applications, okay, read operations are made by query, query or use the query keyword. But since getting data, but since in APIs, getting data and reading it is the most common, or probably the most common thing you will do, you don't need to put is the keyword query. You might do this, but that's not necessary. Okay. However, when it comes to mutate the state of your data with like create, update, and delete, right? Uh, then is when you use the keyword mutation. Okay. Cool. So mutations are very similar to query underneath the hood, and the key thing is that we use mutation keyword that we're about to make some change and not just to fetch some data. So these are the two type of main operation that these operations are the two query and mutations are the two type main operation that GraphQL servers support. Okay. So how do we make mutations? Okay. 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 So now that I understand what mutations are, okay, I'm going to look is at implementing mutations on the server.
Welcome back. How do mutations work on the server side? In this video, we'll implement two mutations. First, the ability to add new products to our product model. And building from there, we'll add the ability for users to add new product reviews. Sounds fun? Let's do it. Where do we start? With GraphQL, it's always by looking at the schema. Here in our products.graphql file, right below our queries, we'll add another root level type, which will hold all of our mutations. Our query type includes all operations that just read data, while anything like adding a new product or a new product review goes in the mutation type. We'll start with add new product, which will accept some arguments that capture the data we need to create a new product object. Let's grab those fields. We'll have one argument that takes in the ID, which is of type ID and is required. We have a description. That's a string and also required for every product. Next, we have the reviews. But it doesn't really make sense for a product to be created with some reviews already attached to it. The reviews are added by users later on. So luckily, our reviews field is optional, and we can move on to the price, adding that as the final argument. Price is a float that is also required. Now, as with any query, we can set a return type for this mutation. And we'll say that when we add a new product, we get back that product that we just created. This is a fairly common pattern in APIs to make sure that the right data was saved. There's our mutation. So what comes next? We need to add a resolver for our new mutation. Because mutations are top-level operations, just like our queries, we add them not under the query object, but instead under the mutation object, which is also a map or an object that takes the name of our mutation, so add new product, and sets it to some resolver function. We'll use this anonymous function, and the arguments to our resolver are the exact same as with our queries. The first argument is this parent, which we won't use, so we're going to set that as underscore, following the same convention as before, but we will make heavy use of these args that were passed in, which contain our product data. What is the body of our resolver going to look like? We're going to make some function in our products model that will add a new product. And we're going to put all of the logic to create a new product and save it to our data model in this function to keep our resolvers as thin and small as possible. We want these resolvers to be independent of whichever model we choose to use, whatever database we're using, and any other implementation details. All we're going to do is pass in all of our args into this function. The arguments we need are args.id, args.description, and args.price. This function will return back the product that was added, so we'll return that value back as the result from our resolver. That's the GraphQL part. But how does our model implement this add new product function? Let's take a look in products.model.js, where we'll add a function at the bottom that we'll call add new product. And this function will accept our three arguments: ID, description, and price. We'll create a new product in a constant, let's call it new product, and that's going to be an object which contains our ID, the price, the description, and also we should set our reviews field to either null or better yet, an empty array to show that this fresh product has no reviews. Now, to be consistent with our pre-populated products array here, let's add an empty reviews array for each of our test products here. So reviews is an empty array, and for blue jeans, we also have reviews being empty. Back in our model function here, we'll take this new product and push it to our products database, or in our case, the in-memory list of products. We'll take the products array and push the new product we just created. Our mutation returns back the product that was just created, so we'll return back this new product, which will come back from our model function here, back into the resolver, and finally be returned back to the client that added the product. Last but not least, we need to export our add new product function. Let's test our work. So we'll start up our GraphQL server. Here in Graphical, let's try adding a new product. Just like with queries, we can make multiple mutations all with one trip to the server. So above our add new product review mutation, we'll add a add new product mutation, where we create a product with an ID that's, say, orange jacket, and the description is going to match our ID. So description will be orange jacket, which is going to be a bit more expensive than our shoes. So we'll say the price is $70.55. And what we'll get back from this mutation is the ID of the product and any reviews, which we decided is going to be empty. GraphQL is now going to try making two mutations, only one of which is implemented in our server. Let's see what happens. We're getting back a few different errors. Notice how helpful GraphQL's error mechanism is. It's returning back everything that's wrong in all of the operations that we're trying to make. So at the bottom of our errors here, we have a message that says, cannot query field add new product review, which makes sense because that mutation doesn't exist on the server. And it even suggests that we might have made a typo and instead meant to add a new product, which is a mutation that does exist. Okay, so this error is expected, but this first error, what's that all about? Field reviews of type review must have a selection of subfields. Of course, the reviews we're getting back from our new product is itself an object, which means that, as with any GraphQL query, we need to select which subfields we're interested in. Maybe it's just the rating of each review. It shouldn't really matter because our reviews will be empty. All right, let's see what comes back now. Just the one error that we expect because add new product review doesn't exist. So we can cut this for now and try making the single add new product mutation, which works. As expected, we're getting our new orange jacket with an empty reviews array. Things are working great. Let's add back this add new product review mutation, take a quick break, and come right back to add this second mutation to our server. I'll see you after the break.
Okay. So with that, I'll see you in the next video. Take care. Bye-bye.